So we will work out the another example for bode plot. Is the open loop transfer function given like this. You have to convert this one into time constant form. The purpose is to convert in time constant form is k value can be calculated and as well as frequencies can be taken as directly by coefficients of the s terms. Okay, that is 10 by 1 plus s by 0.5 whole cube s square by 2 2s by 2 plus 1 whole square. It's 2 taken outside becomes 2 square. Okay, so this becomes 10 by 4. This 2.5 by 1 plus s by 0.5 whole cube s square by 2 plus s plus 1 whole square. So here we have two corner frequencies. First corner frequency existing at 0.5, second corner frequency existing at omega is equal to root 2. Here the coefficient of s square means we have to take the root 2 for the corner frequency. Okay, for this one we have to calculate the initial slope. Now initial slope is equal to 0 dB per decade because no zeros or poles exist at origin. So initial slope will be 0 dB and the initial magnitude is only depends upon the k. In this case that is equal to 20 log k is equal to, here k is equal to 2.5, that becomes plus 7.95 dB. Now we'll construct the bode plot. This is 7.95 dB. The same slope is 0 dB per decade. 0 dB per decade is maintained till it reaches to the first corner frequency. And it is 0.5. Omega is equal to 0.5. 3 poles has been added. Here 3 poles has been added. So resultant slope will be minus 60 dB. This is minus 60 dB per decade. And the same slope is extended. The same slope is minus 60 dB slope is extended up to the next corner frequency. Next corner frequency is at omega is equal to root 2. At omega is equal to root 2, slope is minus 80 dB slope has been added. At omega is equal to root 2, minus 80 dB slope has been added because s square 2 zeta omega ns plus omega n whole power square. This equation corresponds to the slope of minus 40 dB because it has a square term. So the total slope will be minus 80 dB. Here minus 80 dB per decade slope has been added. Okay, so resultant slope will be minus 140. Minus 140 dB per decade. Okay, at omega is equal to root 2, right? So we need to find out the magnitudes now. Magnitude at 0.5 is same as the initial magnitude because the slope is 0 dB, and the next is magnitude at root 2, that is equal to slope minus 60 is equal to magnitude at 0.5, magnitude at root 2 log 0.5 log root 2 comes as magnitude at 0.5 is 7.95 dB as magnitude at root 2 log 0.5, 0.3 minus 0.15 comes as minus 19.08 dB. So the magnitude at omega is equal to root 2 becomes minus 19.08 dB. Okay.